Happy Friday. Finishing up. Kind of stopped, I think, halfway through problem number 4. So we found the normal vector for the plane. All that's left to do now is find the equation. Have the normal vector. We have 3 points to choose from. Does not matter which point we choose. Let's go ahead and just use, I think I used the point 1, 2, 3 again. That's what, -4 minus 2 is -6. -6 is -12. So D is -12. And that's our plane. What? Where did you go over there? Yeah. Let's try and get this somewhat. Oh, that kind of looks like a good view. Except for that X again being somewhat hidden. There we go. These. Need A. There we go. Now it has to find the shortest distance between a point and a plane. So this is how it's defined. In fact, whenever you're looking for a distance between a point and a plane, it is always the shortest distance, right? We discussed that. So it's the projection of the line segment QP naught onto N. Where P naught's obviously our point. Q is any point on the plane. N is obviously the normal vector for the plane. Do the algebra. That formula is just the absolute value of the directed line segment QP naught dotted with N over the magnitude of N. We need Q. Remember, it's any point on the plane. Isn't 0, 0, 2 on the plane? So why not use that for Q?
How did you get 0, 0, 2?
Look at the equation of the plane. It's 5 times Z, right? 5 times 2 is 10, minus 10 is 0. Then the other two would just be 0. And I also could have used 0, 5, 0, right? Specifically, any point that satisfies that equation, you can use.
This is for Q.
Yes.
Okay.
Because Q is a point on the plane. And so basically any point that satisfies that equation, you can use as Q. I'm going to say that exists on our plane pi. Oh, wait, I need Q. I need the directed line segment now, QP naught. Oops. One, two, one, right? Now I can do this. So absolute value. That directed line segment QP naught dotted with N, we know N. 3, negative 2, 5. 3 minus 4 is -1, +5 is 4, so absolute value of 4. divided by now the magnitude of n. 9 plus 4, 13. 13 and 25 is 38. Go away. Go away. It's cute. Distance is 4 over root 38.
What does it represent again?
That's the normal vector for the plane. Is that, yes.
Wait, where did we get it?
Remember the equation of a plane? AX plus BY plus CZ minus D is equal to 0?
Yes.
Or plus D is equal to 0?
Oh, wait.
Right. ABC, isn't that the normal vector? As I said, finding the normal vector of a plane is very simple if you're given the equation. Don't overthink it. It is left to you to verify that if you use a different point Q, you still get 4 over root 38 as your distance. Also in this video, I think it might have actually been a different video, but same lesson, is the idea of quadric surfaces. Sadly, I can't find any good problems for that outside of your textbook. So I just assigned the practice problems for your textbook. We won't be dealing with that in class. Right, but quadric surface is just an extension of the conic sections from Calc 2. Except now it's in 3 dimensions. So go through that, recognize the forms of the quadric surfaces. Your textbook has a nice table that gives you the, I think it's 6 of them, as well as their general form. So recognize those. That almost finishes up geometry of space. There's one thing left to do with the geometry of space aside from vector valued functions, and that is different coordinate systems. Specifically cylindrical and spherical, which of course we'll look at next week. Do you have any questions on this stuff so far? It's all fairly straightforward, right? Calc 3 is easy.